Hey folks, my name is Bharath Hemachandran. I've been in the IT industry for almost 20 years now. And over the last 2 years, I've been concentrating a lot on using AI/ML in software delivery. What's happening today is that companies are investing a lot of time, effort, and money into figuring out how to use AI/ML to solve business problems that are relevant in the industry today. However, the returns that people are getting back in terms of being able to leverage AI/ML successfully are limited. Let's take a look at why this is and perhaps take a look at a framework that can help improve the chances of success in terms of determining whether to use AI/ML or not to solve a particular problem. So this particular presentation will quickly run you through a framework that can be used to identify whether a given use case is a good candidate for using AI/ML or not. So the first thing that we really need to understand when we talk about this framework is that not every problem is solvable using AI/ML. As I mentioned earlier, in today's environment, given the buzz around AI/ML and the fact that you can use generative AI easily, and that generative AI and similar technologies have democratized the use of AI/ML in the industry, it is very important for us to first of all understand that we need to question, given a particular use case, whether we really should or can use AI to solve that particular problem. It is very important to have a repeatable process that can be used uniformly across the decision-making process by stakeholders to first of all determine whether a POC or taking a use case from its requirements phase to a POC phase. So let's take a look at one possible framework that can help us take a look at this. So this particular framework was created or is created by me as one particular solution or one potential solution to evaluate a use case that you might have in order to solve a particular problem. So how do you really overcome this urge? So we've talked a little bit about what is involved in this particular problem. Use cases are aplenty in terms of what you can really use. So we'll take an example of a use case going forward. But the first important step that you need to understand when you get a use case and are asked to determine whether you can use AI/ML for this is to take a step back and understand what does it mean to accomplish this particular use case. What are the inputs? What are the outputs? What are the different steps that are involved in taking this particular use case from start to finish? Before you can even get to the requirements or the technical aspects of a particular use case, it's important to first of all understand what are the sub steps or the sub processes that are involved in a particular step. This is relevant regardless of whether you have a business use case that you're trying to solve using AI/ML or a technical use case that you're trying to solve using AI/ML. Common use cases for testing, especially in the testing world today, are creating automation scripts, for example, or creating synthetic test data, which we'll cover a little bit using the framework. There are many, many other use cases that you can think of from a testing perspective, such as looking at requirements, creating documentation, etc., where you can try to apply AI/ML or some flavor of AI/ML in order to get this to completion. However, take any of these use cases before you actually evaluate the use case as a whole, break it down into different steps. So we talked about creating synthetic data or creating test data as a potential use case to solve this particular problem. So the first step, as I mentioned, is to break down the process of collecting data into multiple steps. And as you know, the first thing that you really need to understand is that creating test data is not a binary action. It involves identifying, data requirements, figuring out what are the scenarios for which you're trying to create that particular data, identifying what data needs to be created itself, the data types and the length of data, the size of data, the structure of the data, etc. And then you would actually go about, creating that data itself. Once you create that data, you would typically either load it into an environment for usage or store it somewhere or process it in some way that it can be used further downstream. And the last step that you would typically do is to validate the integrity of that data. So you've created it, but you need to know if it's usable or not. And this part is extremely important. So as you can see, there are various steps that are involved in the creation of test data. Let's take a look at each of these steps. But before we, identify the steps themselves, just a couple of pointers. Breaking down things into steps is very important. However, we should not be too granular or too technical when it comes to breaking down the steps. So while we want a certain level of abstraction in terms of identifying what each step is, we should not get into the nitty-gritty of identifying what that particular step is upfront. Take your time, make sure that the step is granular but not too specific, where you have to think of too much in terms of details, but at the same time, that it's not too high level where it can be misinterpreted or reevaluated by different people taking a look at it. It should just have enough information for it to be able to identify what you're trying to do. So in this particular case, where we are trying to create the test data, identifying data requirements is something that is a very manual process. It requires communication, it requires collaboration between different stakeholders, between different teams, and is not something that is very amenable to automation or some kind of scripting. Sure, you can attribute some aspects of it in terms of perhaps reading old documents or trying to identify patterns and stuff like that. But overall, the process of gathering what needs to be done, confirming that with the relevant stakeholders, and making sure that you have a proper set of requirements is a step that should be done manually. The second step of determining test data scenarios, again, is probably better done manually rather than creating some kind of automation around it. So similarly, if we walk down each of these steps, we would identify that the process of actually generating the synthetic data is probably the one that is best suited for some kind of automation where we can use some kind of scripting. So breaking down these steps helps you atomize or helps you make the process of figuring out where to use AI/ML a lot more specific, which makes it easier for you to accomplish the scope of or to which makes it easier for you to define the scope of requirements, to define the inputs, the outputs, and verify what you need to do in order to make sure that it works properly. So once you do that, the next step would be to identify, does this really make sense? Are there stakeholders that are going to be interested in this? What is the value proposition of using AI/ML versus manually doing it or being able to do it using some other way, right? Using automation scripts or some other existing tools or processes, etc. Is there a clear return on investment in terms of time, in terms of efficiency, in terms of quality that you would get using something like AI/ML, which is better than what you're doing right now, right? So if you're primarily using a very manual process that takes a long time to do things, maybe it is a good candidate for AI/ML. However, you need to make sure that whatever you are trying to do in terms of defining the value proposition aligns with the stakeholders in terms of the support that you will get from the various parties, the interest that you will get from the various parties, and of course, whether it aligns to your existing organizational goals or initiatives. So the reason why this is very important is that it helps you identify whether something like this makes sense for your company or not. The next thing that you would need to take a look at is to identify whether this particular solution is technically feasible today or not. And while I mean, if you don't have too much information or too much knowledge in this particular field, it might seem like a daunting prospect. It's very important to understand that there is a certain research that is required into this. Are there existing solutions or tools or platforms that enable this kind of solution, for example? So if you are able to do a little bit of research, you will find out not only at a high level whether this particular solution has been repeated earlier, or even you might even get in more details in terms of what algorithms are being used, what kind of data do you need, what kind of infrastructure support do you need, what kind of skills do you require in order to be able to complete this kind of task. So getting all of these things done is perhaps the easier part. The tougher part is, taking a look at, is this even the right thing for me to do? Should I be completing something like this using AIML? Is it ethical for me to do so? So the reason why ethics plays a big part in today's world is because AIML is very prone to ethical failures. So when I say ethical failures, you can take a look at the data, for example. When you have a person that's taking a look at data and processing it, the chances of that person being able to take a fair-minded call in terms of whether you should be using it or should not be using it is perhaps greater than giving it to a random algorithm and asking it to crunch a bunch of data. Are things like data privacy, data security, uh, you know, uh, privately PII data that is exposed, etc. All of these are calls that people need to take in order to use AIML for a particular solution. So these are all extremely important things to keep in mind before you even start delivering on a particular solution. Now, you've figured out that this is a workable solution, that it has some kind of technical merit to it. It has some kind of, uh, you know, uh, it has some kind of value proposition that is useful to stakeholders. However, you also need people to deliver it. You might have the infrastructure to do so. You might have the resources in terms of money, in terms of the tools, etc. But do you have the people to deliver this? Something with a very high learning curve is going to be difficult for people to pick up and deliver quickly. The benefits of AIML are touted that it is something that helps you, with a quick turnaround. Typical AIML projects today have reduced the software delivery life cycle or are expected to reduce the software delivery life cycle by quite a bit. If they do not do so, if you do not have the right people or the skills to be able to do so in your team, in your existing set of people, it's going to be very difficult for you to be able to pitch and create or take something further in terms of what you can do with this. The next thing that you would need to do is, so far you're saying that it's technically feasible, it has a value proposition, you have the right people to deliver. However, it is very important for us to also understand that AIML has a lot of fuzziness attached to, whether it is compliant with today's legal regulations, whether it is compliant to today's organizational policies. A lot of organizations have not, created uh, ironclad policies that are easy for people to understand in terms of what can be done and cannot be done using things like AIML. So for example, in your Word document, when you get an automated spell check in your document, a lot of people, do not understand that that is an example of AIML. Should AIML be used over there on sensitive documents? People don't usually turn that off. However, they would be very careful in terms of securing that document, making sure that it does not get exposed publicly. But there is a use of AIML that reads that particular information for the spell check, for example. So can you use something as omniscient as a spell check in a sensitive document? So these are things that you need to understand in terms of policies, in terms of not just governmental policies, but also countrywide policies in terms of whether these things are possible or not. So, for example, when you're creating test code, is it ethical for you to use test code that has been trained on code that maybe the right people have not got the the accreditation for, or people don't know that their code has been used for something, for example? Do you know the correctness of that code? Would you use it in production, for example? So these are all things that need to be factored in when you're talking about, something like this. The last part is you need to worry about whether the code, whether the result is verifiable or not. So as I've said, you need to have a certain set of inputs, but you also need to have a certain set of outputs to understand whether you're meeting the initial requirements or not. If you're not able to do so, everything that you've done till now is not going to be very useful. So as we talked about, the various parts of this particular framework are: one, breaking down the larger solution into a bunch of steps, identifying the best candidate for AIML within those steps by applying a bunch of filters, such as, is it something that is of value to someone? Is it going to help in some way that is adding value to the team or the project in some case? Is it ethical for me to do this? Is it correct for me to use this from a governmental or organizational policy perspective? Is it technically feasible? Is it possible for me to deliver this using the infra, using the people, and using the skills that I have? And lastly, is it verifiable? So I hope that you find value in this particular framework. Please question, any use cases that you get in terms of being able to use AIML, etc. And make sure that you understand whether you should be using AIML or not in the first place. Because without understanding whether something should be done or not, you are doomed to failure if you put in a lot of effort and time and you find out that it is not going to help out in the first place.